So, little quick summary review here on what we've done so far. I basically wasted a whole week talking about Newton's laws. Maybe wasted isn't the best word. We spent a day drawing 3-bar diagrams. That was yesterday, right? So now we're going to put it all into play, into action, and we're going to actually solve some problems. So today, you have 4 sample questions here. I'm going to do them all. It won't take that long. You won't have to listen to me too long today. And then you have 2 sets of problems. We'll do a little practice. So let's begin. There's really only 2 formulas that you need. In addition to the kinematics ones that we've already done last unit. So it's a good review of some of those. So if you're still struggling with those, then this would be a good chance to practice those again. So those 2 formulas, Newton's second law, F net equals ma, mass times acceleration. And then what's this one right here? F net equals Fa plus Fx. What do you think those things stand for? Applied force. Yeah, applied force and friction force. Now technically, Braden, here's the listening part. I've sort of let you guys visit for at least 8-9 minutes, but it's now my turn. And I'm warning you right now, I'm moving you today. I got a nice empty table right there, ready to roll. Someone's moving today. Who's it going to be? You don't care? Okay. Giving you fair warning. Really, F net is simply F1 plus F2 plus F3, and I could spend all day writing those. F net means the sum of all the forces. Okay, so this is just sort of a special case of that. The net force is the applied force plus the friction force, if that's all the forces that there are. It's F1 plus F2 when the applied force is the 1 and FF is the second one, right? Okay, so don't worry so much about knowing this formula. Just understand that F net means the sum of all the forces. Okay, so let's read the question. A constant force acts on a 12 kilogram mass, changes its velocity from 4 meters per second to 18 in 3.5 seconds. What's the force? We are solving for F. It's a constant force. What kind of force is this? It's the applied force, really, right? What's the applied force here? What other things do we know? We know the mass is 12. Again, some of you may find this writing stuff down on the side helpful. Some of you might just think you can do this. Some of you can just sit there and not do anything. It's whatever works best for you. If it's not working for you, change it. Changes its velocity from 4 to 18. That's telling me the initial is 4 and the final is 18. And I got one last thing. The time is 3.5. Those are the things that I know, right? FA is question mark, mass is 12, VI is 4, VF is 18, and the time is 3.5. Okay. I'm looking for applied force. Is there a friction force? There is not. So really, right, the applied force is equal to the net force. That's the only force there is. The net force is the applied force. Okay? So I'm really solving for F net, so I need M times A. Do I have M? I do. Do I have A? I do not. So step 1, find A. How do we find A? Delta V over delta T. I don't have delta V, do I? I got to find it. Delta V is VF minus VI. Did you see how I sort of worked backwards there in my mind? Delta V is VF minus VI. 18 minus 4, 14. You can all do the math. The arithmetic's not hard. It's the logic, right? That's the steps. Notice once again, got my equal signs lined up above one another. Yeah, my handwriting's messy, but it's organized. Now I'm going to go. 14 divided by 3.5. I think that's 4 meters per second squared. And now that I have my acceleration, I'm going to F net equals ma, mass of 12, acceleration 4, 48 newtons. Answer, bottom right-hand corner. That's where answers live. What does this thing mean right here? Therefore, you guys have seen that before? The 3 dots? Do they still use it in math? Mr. Ray still use it? Somewhere? No? French, they use it? No? Only if he's rushed. Really? Yeah. 3 dots in a triangle means therefore. I have no idea where it comes from. Probably 3 marks. I'm not probably going to give you that extra mark for that. 1, 2, 3. It's hard? Not too bad. It's going to get harder, I'll tell you that. Okay, let's add a little degree of difficulty here. Here we have a block being pulled by a rope as shown, 25 newtons of force is being applied. I don't think you guys have the picture, right? Okay, so you probably want to draw, you know what, let's just do this for a second. Block is being pulled by a rope as shown, 25 newtons of force is being applied, and the friction force is 5. So to draw the free body diagram, right? Now, some of you might be saying to yourself, should there not be weight force and normal force? And the answer is yes, there should. Okay? However, years of experience tell me that those forces aren't going to have anything to do with it going left or right. So I sort of left them out. Probably shouldn't. So I'll draw them in there. So we got 25 newtons is my, I'm going to do it this way this time. That's my applied force. This is my friction force. And there's a problem with this question, isn't there? Right. Do you guys have it in your question? Yeah, you are mad. I can tell. It's like, oh. Really? It's not even in the question? Mr. Bennett. It's a mistake before 9:30. Okay. Just let's make it 10, because 10's a nice even number. Let's make it 10 kilograms. Somebody remind me at the end of this period to make that change on the official sheet. I probably say that every year. We'll make it 10 kilograms. What is the acceleration? And if the force applied for 4 seconds, determine the velocity. So this time we're not looking for the force, we're looking for the A. From forces to A is, we're going to use F net equals ma. Do I have, the net force? I don't, so I need to find the net force. Net force is applied force plus friction force. Now I'm just going to stop there for a second. And I'm going to wait for someone to ask me the question that someone always asks right when I get to this part. Is it negative? Excellent question, Dan. Well done. Should it be FA minus FF? Well, it's going to end up being that, but really, it's the formula. Net force is add all the forces, right? So really, a better way to write it would be 25 plus minus 5. You end up subtracting, but really what you're doing is you're adding negative 5 because it's opposite. Okay? Because I don't want to get away from that idea that the net force isn't the sum of all forces. 20 newtons. Problem, Reese? No. Problem? No. The negative 5 is because the 5 is to the left, and it's opposite the plus 20. Would it work if I made this negative and that positive? Absolutely. They just have to be opposite, right? But traditionally, left is negative, right is positive. Okay, so I got my net force is 20. Notice my equal signs lining up. I'm going underneath here. F net is equal to MA. 20 is equal to 10A. Now, can you solve these? I really, really hope so. I know what's in grade 11 math. This is way beyond grade 11 math. You have to be able to, this has to be automatic, without thinking, like breathing. You have to know how to solve that. A is equal to 20 divided by 10. 2 meters per second squared. If you don't know how to do that, you and I need to sit down and talk about solving equations. That's your job, to come and say, Mr. Bennett, I need help with solving equations. Because they're going to get a lot harder than that. 2 meters per second squared is acceleration. Now, with the force applied for 4 seconds, determine the velocity. I really mean the final velocity, I think. Okay, because it's part B, I'm going to label it part B. Because I'm trying to sell the teacher that I know what's going on here. An organized solution makes that sell job a whole lot easier. Okay, the force applied for 4 seconds. This is my acceleration. A is equal to delta V over delta T. My change, oh, again, there's another one of those, you got to be able to solve that. Like, you have to know that's multiply both sides by 4. Involuntary is breathing. The velocity changes by 8 meters per second. Is that the final velocity? It might be. Vf minus Vi. What's the initial velocity? Well, it didn't say, so if it doesn't say, you can assume it's 0, which means then, of course, the final velocity is 8. Here. Is the final velocity always going to be equal to the change in velocity? Is the Vf always going to equal the delta V? No. When is it? When is this equal to this? When it starts at rest. You'll see that difference. So don't always assume that delta V and Vf are the same. Okay? You know what? I'm going to add a part C to my question. Have you guys got enough room for part C?
Yeah.
Oh. Yeah, that is like the worst I've ever written. Sometimes the angle that I'm at too makes a difference. Might as well be like Charlie Brown's teacher. Just yeah. There, how's that? I'm glad I thought of this, because what I'm about to do here is the most common mistake that grade 11 students make. How far does it travel? How far does it travel? Now, put your pens down. Put them down. Watch carefully. V equals d over t, right? Do I use the 8? Do I use the 2? What do I use for v? 8? I hear a no. That's the final velocity. It's accelerating. Do we know this is actually average? Do we know the average? We do not. That's why I told you to put your pens down so you wouldn't write it down right away. We do not know the average. V bar is equal to VI plus VF over 2. You can do it in your head, I'm sure. 0 plus 8 over 2. So the average is 4. The average of 0 and 8 is 4. And can I use that over here now? Yes. 4 is equal to D over my time was 4 seconds, so my distance traveled is 16 meters. That question will cause about 1/3 of you to lose marks on the upcoming test. Guaranteed, because I have written this on so many tests before, I might as well just get a rubber stamp. Save myself the trouble. V bar and delta V are not the same. Just because it's V doesn't make it the same. It's always helpful when there's two people with the same name in the room. I'll use Alex and Alex. They are not the same. Or Brady and Brady. Oh, we got two pairs. Thanks, Josh. They are not the same. Right? V bar and delta V are not the same. I cannot emphasize that enough. Well, I guess I could do a little dance or something or other and yell. I don't think that's going to make any difference. Okay. Here's a completely different kind of question. Promise there's only 2 more left. I'll be done by 9:30. A 100 kilogram crate is being pulled in 2 directions with different forces, 250 newtons south and 150 newtons east. If the friction force is 50, what would the acceleration be? Now, there's usually sort of 2 style of questions. Don't write this down. There's the kind of question where you're looking at it sort of sideways, sitting on a table or on the floor or something. You're looking at that sideways view. Is that what's happening here? No, this says south and east. So we're going to have to change our point of view to a sort of overhead bird's eye view. South and east, not this one. Right? So there is our free body diagram. South and east. Shall we label this one F1 and this one F2? I heard someone say, where do we put the friction? Where do we put the friction? He repeats the question back. Well, friction always opposes it doesn't oppose the forces, F1 and F2. It opposes the motion. So which way is this box thing going to go? It's going to go like this, right? It's going to go like this. It's going to go more south because the south is bigger. In fact, I probably should have done it to scale. Right? So it's going to move kind of like this, right? Which means then that my friction force is kind of like that. But we don't know the direction, do we? Okay? And don't write this down. The net force is, we'll call it F1 plus F2 plus FF. Do not write this down. So can I just do this? Can I do that? Why not? Yeah, these are vectors. This is 2-dimensional. You cannot do that. Some of you are going to try. Don't do that. This is a vector question. No, can't be done. So what am I going to do? I'm going to have to add my F1 and F2. Do I know? I'm going to add my F1 and F2 as vectors, and then I'm going to subtract my 50. Okay? So I'm going to redraw it like this. 250 south, 150 east. And I'm going to label this one FA. The FA is like the sum of those 2 applied forces. FA is F1 plus F2 in vector format. So back to our old friend Pythagoras. FA squared is going to be 250 squared plus 150 squared. You'd think after all these years I'd have these answers memorized. Oh yeah, write this down. And I get FA equal to 291.5. Again, this is mathematics that I consider involuntary at your level. Do you want to show that in between step? You go right ahead. If you want to do that, be my guest, okay? I think we can skip it. If you want to show what 250 squared is and what 150 squared is, and then add them together, and then show the square root, make it about 5 steps long, I'm not judging. You go right ahead. If that's what works for you, you do it. Okay, so the applied force is 291.5. Next step, F net is FA plus FF. Oh, by the way, you're going to try example number 4 right away on your own. Just getting you a hint, heads up. The applied force, 291.5. Friction force, minus 50. FA plus FF. So our net force is 241.5 newtons. I'm asking for the acceleration. I didn't do my sort of backwards plan, did I? I sort of forget sometimes. I just do it in my head without, yeah. Okay, so now can I find the acceleration? Again, involuntary arithmetic. $241.5 divide by 100. Is that the end? Yeah? These guys said yes? Reese said yes? Reese is wrong. The sort of general rule is that if you're given a direction in the question, there's a pretty good chance you're going to have to give a direction in the answer. Not guaranteed, not absolute, but pretty good chance. Do we need a direction here? Yeah, we do. How come? Because acceleration is a vector. So the acceleration is happening in this direction here, right? That's the direction of the acceleration. That's not part of the free body diagram, so I'm going to erase it. And it's going to be whatever this angle right here is, isn't it? Right? Remember vector addition, subtraction? How much fun that was in the first unit? We get to do it again. Do you see how it's building this whole pyramid of physics that we're building here? Theta equals inverse tan, opposite over adjacent, 150 over 250. Make sure your calculator's in degrees. I get 31 degrees. Do I leave it just like that? Braden, what are you doing that? Cracking your back. That's going to be south 30 to the east, right? South 31 east. How many marks is this going to be? Hannah is just, she's like, make lemonade out of it, Hannah. 1, 2, 3, 4. Yeah, you're probably going to, yeah, probably solid 5. See how I showed my work? See how I lined up my equal signs? See how my answer's sort of at the bottom right-hand side? I underlined it. Those are the kind of things I look for. I'm modeling for you. Are you ready to try one on your own? Everyone loves ice cream. It was in the video. Give it a whirl. I'm going to give you 5 minutes to try. So let's go. Okay, let's write down what we have. Mass is 1800. How much force will the engine need to accelerate it? So what am I really solving for? Applied force. And the acceleration is 1.75, and the friction force is, let's write minus 250. Right? The friction force is minus 250.
Why would you have to write minus 250?
Well, I just wanted, I want to be reminded that it's negative. Okay, so I know M and I know A. Well, with M and A, what can I find? I can find net force. Let's do that first. F net is equal to MA. Mass is 1800. The acceleration 1.75. And I just happen to have done this question a lot, and I saw it on people's pages. I think it's 3150. Am I right? No more? Oh yeah, okay, yeah. Not the final answer. Yeah. Okay, 3150. Okay, that, my friends, is the net force. It is not the applied force. That is the net force. F net is equal to FA plus FF. Here's where I can tell the people that want to do the shortcut, because this is what the shortcut people do. They do that and they just do a subtraction. And that, my friends, is wrong. Okay? This is the first lesson in the shortcuts aren't going to cut it anymore. The net force is 3150. So put 3150 in for the net force. That's what it is. You are solving for the applied force, and the friction force is minus 250. And how do you get rid of minus 250? Now, I saw a few people that couldn't do this. Add 250 to both sides, making our applied force 3,400 newtons. Okay? Go ahead, Alex. Can you say that a little louder? Because I know you're going to say this right. I have a feeling. Come on, I know you're right. No, you're... It makes sense because? So, what he said was that, like, if I need 3150 of net force, do I need more than that to apply? Like, if I need 3150 and there's friction, how much more do I need to overcome friction? 250 more. Of that 3,400 newtons of applied force, how much goes to friction? 250. How much is left over? 3150. What does the 3150 do? Accelerate it. Right? You need to push harder than you need because there is friction. Right, Alex? That's what you were going to say. You need to push harder than you need because there is friction. Again, The shortcuts aren't going to work, you guys. You have to show the formula, you got to show your work, and you will get it if you follow those steps. Okay, do you think I'm going to try this question on you again? Oh, yeah. Yeah. Say again? How many marks for that? Probably just 2. Okay, now I hear people packing up. I'm not really sure why. Okay, you have on the back side there's problem set 1. You will notice that at the bottom there are answers. I firmly believe in those. There's a QR code that will take you to the solutions. And on the back side there are answers. I think the QR code takes you to both, I think it's all one document. Okay? I will throw the solutions on Schoology as well, so you can get them that way as well. Okay? They're also available in a red binder that's lying around here somewhere. Get it up there. You should practice. Am I going to say do them all? No. I would be crazy to think you're going to do them all. Go ahead and do them all if you want. Right? But at the very least, by Monday, you should have, how many questions have we got? We got 16. I'm going to say you should do at least 8. Your choice of which one. Until you get comfortable with doing it. Go. I